All right, what is the simplified form of root 3 over root 7? This is similar to using division, but the previous examples, we had a perfect square factor in the denominator. We don't know what root 7 is. We can't leave it that way. The reason we can't leave it that way is it's irrational. We can't ever have an irrational number in the denominator or divide by an irrational number, because it goes on forever and ever, non-repeating. It's like we actually can't do it. So what we do is we do something called rationalize the denominator. Since it's irrational, we need to make it rational, hence rationalize. That's where the name comes from. So it's really very simple. What we want to do is we want to multiply this. We can't just change the value. I mean, I can't multiply everything by 7, but I can multiply the top and bottom by the same value. And as the notes had previously said, we want to multiply it by 1. That's the only thing we can do. Now, if I just multiply it by 1, I get root 3 times root 7, and that doesn't help. So I need to multiply it by a value of 1 that will change its appearance. Meaning I could multiply it by 2 over 2, or 3 over 3, or whatever. But the purpose is to eliminate the radical in the bottom. All right, so hear me out. What we're going to do is we're going to multiply by 1, but that 1 is going to be the denominator over itself. Not 7 over 7, but I'm going to take this root 7 and I'm going to multiply it root 7 over root 7. If I were to just zero in on this root 7 over root 7, root 7 over root 7 equals 1. Anything over itself will equal 1. All right? Now, the reason of doing this is if I multiply, when we multiply fractions, we go straight across. We learned earlier in the lesson that root 3 times root 7, I can multiply the 7 and the 3. That gives me root 21. Now, root 7 times root 7 gives me root 49. And you may be thinking, so what? I still have that radical on the bottom. But look at the radical on the bottom. Root 49, that is just really equal to 7. The square root of 49 is 7. Boom. All right. Now what I have to do is I have to look at this numerator. All right. Can that numerator be simplified at all? Is there any perfect square factors that go into 21? 4 doesn't, 16 doesn't, 25 is too big. So no, this root 21 over 7 has the same value as root 3 over root 7, but this has a rational denominator of 7. So this is the simplified form.